As you could see on the screen, we have these two circuits. We actually work with number one, which you see here. So the question is, analyze the following combinational circuit and evaluate the output as a function of the inputs. Okay. So we follow that step. So first we are working on whatever you see on the left, which is we label that as number one. Okay. So the first step is actually label the inputs output. So we already did that, right? So you have X, Y, Z, and the output is F. If there is no label on the input output, you do that. So you could actually choose any labels that you want. So here we have X, Y, and Z. Okay. So as you could see, some output here, there is no label for that. We need to actually add the label. So see, for example, whatever you have here as a output for these XOR, there is no label for that. I actually add the T here, which is the output for this, the output of these XOR that you see. So right now, I have the label for all outputs, right? So if you're missing any labels for output input, just label that, okay? So here I label this part of the circuit as actually T. So then you need to actually find the boolean function for any of the outputs. So definitely if you start with the F should be base of T and Z, right? But you don't know the boolean function for T. So that means first you need to find the boolean function for these T, then you could write the boolean function for F, okay? So that's the reason I start with T, okay? So if you do that, so what is this gate is XOR. So you already know what is the XOR is. If you have T, which is the XOR X and Y, so the XOR is this. You actually prime the first one and the next one, which is Y plus, then you keep the first one and the prime of the next one. That's actually definition of the XOR, which we actually saw that in chapter 1, right? So the XOR is X prime Y plus X Y prime. That's the definition of the XOR. Okay. So you have actually the T. So now you could actually get the Boolean function for the F, right? So I'm going to write one function for F. So definitely right now, if this is T, this is Z, and this is XOR. So the F should be this. It should be again similar. It should be one input prime, which is T prime Z plus T Z prime. Okay. So, but this function f still is not Boolean function, because if that's function, it should be base of the input variables, which is the input variables here is x, y, z. All right. So if you check your inputs that you have, the input is x, y, z, not t. So somehow you need to replace these t with whatever you already have, which is base of an x and y. So that should be the real Boolean function for f based of the inputs that we have. So I'm going to replace t with what I have here, which is x prime y plus x y prime, replace with this. Then same thing here, replace these t with whatever I got here on the actually left side. Okay, so let's do that. So you tell me if I want to have t prime, okay, so ct prime. So t is this. Could you tell me what should be the t prime? So back to the chapter 2, right? And we learned one of that theory that we learned was the De Morgan, right? What actually De Morgans tell us, I'm writing here. So just remind you about the De Morgan. So De Morgan actually says x plus y prime is x prime y prime, okay? And how about x y prime? It is equal to x prime plus y prime. Remember that from chapter 2. That's actually one of 8 theory that we learn in chapter 2, okay? So right now the t is whatever you have here, okay? So I consider this as a 1 and this as a second one, okay? So t prime should be this prime dot this prime, okay? What is the prime of this? Again, that's another De Morgan, right? So it should be first this prime should be the prime of the first. X prime prime is x plus y prime, right? So then these actually change to the dot base of the De Morgan. So then prime of this. So it should be x prime plus y prime prime, which is just y. Okay, so this is just t prime that I got. Okay, then no change for z plus. So these t, which is I just replace whatever I have on the left side, which is this should be x prime y plus x y prime. So then you have one z prime here, which you add the z prime. Okay. So now, so if you take a look here, so again, the goal is write the function, write this function, Boolean function for f base of the x, y, z, and it should be the standard form, right? So whatever you have here, so if you could distribute dz prime inside this, which is give you two standard form, which is they are midterm, right? But here, that's not the standard, and what you need to do, let's do one thing. I'm going to distribute whatever I have here inside these parentheses that you see here, okay? So then, if I do that, so first it should be this time x prime, so then you actually distribute these prime inside these parentheses, so that you will have this x prime, right, plus x prime y prime, okay? I just distribute this inside these parentheses, okay? Then you actually have a plus, whatever you have here, which is the plus. Then distribute this second one inside this, which is give you again. So I did this, which is give me x prime. So then I multiply x prime, y prime. Right now I'm doing that for these y. Should be y times x, which is give you x, y plus, so this y actually times y, which is give you y prime, okay? So this is what I got, which actually distribute this inside these parentheses. And again, you have z here, no change for that, okay? So plus. So then for the next one, I just distribute these z prime inside these parentheses, which you get x prime y z prime plus x, y prime, okay? Just distribute this inside these parentheses, okay? So we have some actually variables here, which is going to be 0. Let's find that. So you tell me, what is the x prime? Just type on the chat box. What should be x prime? Yeah, definitely should be 0. So this is 0, right? So we have another 0, which is y prime, right? So again, this is actually the 0. So that means I could end up with more simple term here. So I just have x prime, y prime. You have z, distribute these z inside the parentheses. So you have x prime, y prime, z plus x, y, z plus, no change for these two terms. So I just write x prime, y, z prime plus x, y prime, z prime. Okay. So now that's it. So I'm able to write the f base of the inputs that I have, which is x, y, z, right? X, y, z. Okay. So, but for doing that right now, I have a standard form of the f, but if you want to know what is the basic function of the circuit, maybe the truth table is able to help us to see what exactly is the main function of the circuit. So for that reason, I'm going to actually draw the truth table for this function that we found. So you already know the f is related to 3 variables. So you will have 8 different cases in the truth table, X, Y, Z. So you just say 0, 0, 1, 1, 1, 1. So this is 0, 0, 1, 1, 0, 0, 1, 1. The same thing, 0, 1, 0, 1, 0, 1, and 0, 1. So this is F. You tell me in each, based off whatever you got here, what is this midterm number? X prime, Y prime, Z is midterm. Which number of the midterm? Just type it in the text box. Is 1, that's right. So this is M1. What is this? M7, that's right. What is this? M2, that's right. So what is this? M4, that's right. So that means whenever the function is in midterm 1, I actually do this, which is more clear. Okay. See, whenever you have the midterm, the function should be 1, right? So M1 is here, so that the function is 1. M7 is here, the function is 1. M2, where is 2? 2 is here, the function is 1. And what else we have? 4. 4, where is 4? 4 is here, right? In the other places, it should be max term or 0. So I just add this here, okay? So now I get actually the truth table for the circuit, and then you just take a look to this truth table and see what's the basic function of this circuit that we have here. So whenever it's 3, 0, it actually is 0. So whenever that's 0, 0, 1, it is 1. So whenever this is actually 1, 0, it is 1. 2, 1 is 0. This is 1 is 1, it is 0. This is 2, 0 is 1. And it's for 3 is 1. So what I see here, could I tell this circuit able to detect the odd number of the 1 in inputs? Yes or no? If you check, so here we have the odd number, so that we just have 1, 1, right? It's give us 1. So here we have the odd number of the 1. The 1 is just, we have 1 between 3, right? So that's odd. So it actually gives us 1. Here you have 2, 1. So which is even number. So it's got the 0, right? So that means it's able to just detect the odd number of the 1. So here is 1, which is odd number is 1. Here is 2 is even, it's 0. Again, here it's actually is the even 0. Here is the odd, it's 1. So I could actually tell it this is, we call these circuits in the digital, we call that odd parity checker. Okay, that's its name. Okay. So odd parity checkers, what it means, that means this circuit able to tell us the number of the 1 inside these 3 input is odd number or it is the even number. If that's odd number, it's able to turn on the LED. If the inputs actually has the even number of the 1 between 3 inputs that we have, it should be actually 0. So that means if you take a look to the whole process, what we did, we actually had one circuit which we had no idea about its function. So we actually analyzed the circuit and then we end up with the truth table. This is whenever you want to analyze the circuit, all the time you need to get the truth table. So then take a look to the truth table and find some functionality for that circuit. So for this specific case, it's actually, we call that odd parity checker because it's able to detect the actually odd number of the ones in input. Okay. So any question about this? Make sense what we are doing here? Okay, so this is actually what we call the analyzer. I see, as you see, this is exactly the opposite of the design. In the whenever you design, you already know what should be the basic function of the circuit. So then you design the circuit, end up with the circuit which is do that specific task that we want. But whenever you analyze, you already have the circuit, but here you want to understand what's the main or basic function of that circuit, which is you need to find these output based off the inputs that you have, draw the truth table, take a look to the truth table, and with truth table you could actually find one basic function inside that.